Okay, now in this topic we are having three combination. First, observer and source. So source is moving away from the observer. So initial length between observer and source is L. Now when it move, that length covered in T0 timing, that is V as TO. So total distance now, final distance L plus V as TO. Now time taken to reach in at this point, so T2 is equal to TO plus L plus Vs TO upon V. What is this V? V is the speed of the medium. Some wind is there, right? So that is V, speed of sound. So V is called speed of sound in medium. Our medium is atmosphere, so speed of sound in atmosphere. Now Tn plus 1. Now if we want to find timing, the next timing, so we have to multiply with n. Wherever TO, we have to multiply with n. So NTO, again it multiply here also, so NTO, right? Whole equation as it is. Now time interval is between Tn plus 1 minus Tn. So Tn plus 1 minus Tn, that will be NTO plus L whole equation minus L upon V. This is our initial timing. So that is time interval, final minus initial. So that T time interval, now we get this equation, L by V cancel out. We are left with these two terms by N. So we are getting now time interval. So when we put N here, N get cancel out. So we are left with TO into the bracket 1 plus Vs upon V. Remember, Vs is speed of source, which is moving away from the observer, and V is the speed of sound in medium. So if we want to find the frequency with this equation, we have to take reciprocal of this equation. So reciprocal of this equation, that is 1 plus Vs upon V minus 1. So this is new frequency, new zero, original frequency, and this is our velocity term. Now minus 1 by polynomial equation solution, we have to put this minus 1 here. So in multiplication, so 1 minus Vs upon V. So this frequency whenever source is moving away from the observer. Now we have to find whenever source is moving towards observer. So only one term changes, this negative becomes positive here because of that opposite direction. So this is for whenever source is moving but observer is resting. Now second, observer is moving, source is resting. Now observer is moving towards source. So that distance earlier it is here but final here. So in T0 timing, V0 T0 distance covered by that observer. This is total length from initial to final. So L minus VO TO. So timing for that to reach from here to here, TO plus L minus VO TO, V plus VO. So what is VO here? Observer speed. V is speed of sound. Now we have to find that Tn plus 1. Further for that, so we have to find timings, means forward timing of this. So we have to multiply N with TO term, right? Now this is time interval. So NTO, this whole equation Tn plus 1 minus Tn. So this term TV plus VO, right? And this negative term will be cancelled out. So we are left with these two terms only. So NTO minus NVOTO upon V plus VO. Now we can find that time period. So T is equal to TO 1 minus VO V plus VO, right? Because here we have to divide with small n to find this T. Now to find frequency, what is our new frequency? So frequency, we have to take reciprocal of this. By polynomial, we have to give this minus to here, that will be positive now. So by taking LCM, we are getting nu is equal to nu 0 V plus 2 VO upon V plus VO. So this is frequency when observer is moving towards source. And this is the frequency when observer is moving away from the source. We have to small we have to take small change here. We have to remain this negative as it is for observer moving away from the source. So negative as it is, and then took LCM, then we are getting this equation. So whole observer is moving, source is stationary. Now we are getting on the third characteristic. So observer and source both are moving in a direction. So for that, it starts from the simple formula of timing. T2 is equal to TO, start from there, plus L plus Vs minus Vo TO upon V plus Vo. Here, because of relative velocity, we have to subtract source velocity and observer velocity. Now T is equal to TO. So this is complete time interval now, direct. So TO 1 plus Vs minus Vo upon V plus Vo. Now taking reciprocal, taking LCM, we get this equation. We have to convert that equation into frequency form. So this frequency is now equation of whenever observer and source moving with different speed in same direction. This is for same direction but different speeds. And this equation we have to just put negative here. So now this equation becomes whenever observer and source is moving away from each other with a different velocity or with a same velocity, but their directions are totally opposite with each other. So this is the case for when they are opposite with each other. So these are the whole characteristic of Doppler effect.